Haytham Abuelfutuh, co-founder of Flyte.org and CTO at Union AI. Welcome to the Data Exchange podcast and what appears to be our mini tour of orchestration. So, well,
hi, thank you for having me.
Yeah. So let's first talk about Flyte, and then we can talk about Union. So Flyte. So let me quote to you what I picked up on the website. So Flyte is the workflow automation platform for complex mission-critical data and machine learning processes at scale. And then the other quote we're citing is Flyte is helping organizations like Spotify and Lyft build a new generation of products that make elegant use of complex data and machine learning. So with that said, what is Flyte?
Yeah, thank you for the intro, Ben. It's great to be here. So as you said, we did think long and hard about how to position Flyte, and we came up with this understandably mouthful description of what Flyte is. But we can probably break it down into a few different, into the basics. So it is a workflow automation platform. And when we think about the workflow, we think about business processes within an organization that consists of different steps. There's data awareness, there's guarantees of robustness, guarantees of completion. There is desire for collaboration and sharing. So there's a lot that goes under what a workflow is when it comes to a business process in a company.
Yeah. So let me stop you there. So workflow. Let's see if I have this right. So for me, workflow has a few key components. There's a scheduler. There's an executor. There's some sort of metadata store to kind of keep track of things, and then monitoring. So does Flyte kind of have all of these components, or am I missing something?
It does have all of these components, yes. So we can dig a bit deeper into the technical details of what workflow engine is, but you are absolutely right. All of these exist in Flyte and a bit more. Things like what exactly are you running are not really captured when you say an executor. We typically in the traditional systems that are called workflow engines, they run a certain kind of workloads in that executor. There is always maybe a Python function or some native Go process to run, or something like something that's sort of the hallmark of that engine that they run as part of this process. One of the things that sets Flyte apart from the crowd is that it's agnostic to what each process looks like, how it runs, and so on. It's very extensible, adding sort of different types of things to run. Just as examples, we have you can write like one workflow that invokes Python functions and also invokes a Go process or some native container image that has nothing to do with Flyte, all within the same workflow, and then pass data between them, and maybe run a map job of like an array job of processing thousands and thousands of data, and then a join step in a completely different process. And from a user, like from an author perspective, they all look sort of the same. They are still giving the same experience of I'm calling a function that takes inputs and produce an output, regardless of how that sort of function runs under the hood. So yes, an executor, but I mean there is more to it than that. The scheduler, you can set schedules on workflows. They can run on some cadence. They can run as a response of some external events. They can, of course, trigger external events, which helps when you have like some data, some complex data processing, pipelines that's sort of handing over pieces of data or processed data from one to the other.
So in the
of course, the automation.
In the website descriptions, you make you explicitly call out machine learning. So many of the orchestration tools,
yes,
yeah, many of the other orchestration tools don't go out of their way to call out machine learning. And by the way, Haytham, maybe take off your AirPod. Maybe just speak through the laptop. The AirPod is a bit choppy. Yeah.
Okay.
Yeah, it's a bit choppy, unfortunately. Yeah, much better. Yeah. So you folks explicitly kind of go out of your way and call out machine learning, which most of the orchestration tools cover machine learning too, but they don't go out of their way. Is there a reason behind this choice? Yeah.
Yes. So we saw that looking at the sort of orchestration market, there are a lot of very good tools that can be used for data processing, and Flyte is certainly one of them. There are many others in the same market. And we see that there is a huge gap in serving machine learning workflows or machine learning pipelines, in that, as you said, all the other tools just think of them as, if I can be used.
Actually, stop there. So for our listeners, why do you make a distinction between a data pipeline and a machine learning pipeline? So what's special about a machine learning pipeline?
That's a great question. So let's like a typical machine learning pipeline involves like a few different steps. You can query data, do some transformations on the fly. You can train a model, and then you want to start some testing or some like maybe A/B testing, serve the model and collect data, which from a very like a 10,000-foot view looks very similar to any typical workflow, not even a data workflow. It's just a workflow, right? But there are specific needs there that are not common. The ability to deploy a high available service, that's a machine learning requirement. You don't need that in data. You're not serving mostly offline processing of data. You want to do maybe online predictions in a machine learning workflow. You again don't necessarily care about.
So in your notion of machine learning workflow, it's not just exploration and training; it's all the way to production and deployment.
Yeah, so we skipped a part in the description here, which was the complex and mission critical part. So we do want to make sure that Flyte isn't, or make sure people understand that Flyte isn't just a tool you can use to explore your data or play around with like the workflow or how you will structure that. It's there to help you with that, but also there to help you take this pipeline all the way to production, and help you observe that, monitor that in production. There are a lot of tools within Ship with Flyte out of the box for building dashboards and alerts and monitoring the resource usage, help you with cost analysis and cost optimization. So we did. It's not right again that this very first step, which is where everyone starts. Like you open up a Jupyter notebook and you're exploring, some tables and
you might do some complex data transformations, right?
Correct.
Yeah. Data integration, data transformation. That's kind of the classic data pipeline picture that people have. But what you're saying is ML pipelines. Now you start getting into training, maybe evaluating the model, then maybe serving the model, right? So.
Yep. And I like we also explicitly say data and machine learning processes, right? Because we there is I don't think you should use different tooling for these two different use cases. And there is a reason for that. The main reason is that you want to be able to track data lineage as it transforms from the very, the source of the data, whether that's like, sensors coming from a car to, data collected on the web to whatever, what have you, all the way to an online prediction that ran in production. And you want to draw that line. You want to be able to say, well, this was a bad prediction. Why? And you want to work backwards through the training pipelines, through the data transformations, all the way to this.
Which, by the way, anyone who works a lot with machine learning and production knows that when a model starts degrading, you do root cause analysis, and almost all the time it's a pipeline.
Yeah, that's yeah. That's true. For the most part, that is definitely one of the possible root causes. But which pipeline too is a question, right? Like you, by the time you are getting an online prediction, you probably ran through like 10 different pipelines, from data transformations to training to serving, right? And you want to be able to track the version of the code that ran to produce that prediction. With the data storing, like tracking all the revisions of the versions of the pipelines and all of that all the way through helps you track that.
I just want to clarify. So the role of the an orchestration tool like Flyte in terms of ML workflows is you may have different tools, right? So you may be using a tool for data transformation, a tool for training, a tool for experiment management, a tool for evaluating models, and then a tool for model serving. So Flyte is orchestrating what you're doing across all these tools. So Flyte has to be able to somehow talk to these tools, right?
Yep. This is a great way to describe it. Flyte isn't trying to reinvent how to serve high availability.
So Flyte is not a model server.
Correct. Our, I guess, listeners should not think of Flyte as a replacement for Kserve or Seldon, or a replacement for a DBT
or Racer.
It is not. It is a tool for orchestrating all of these tools, and this is why we focus a lot on making it extensible and pluggable. There are a ton of existing plugins. I lost count of how many right now.
So in each stage Flyte has integrations with some of the most popular tools for each stage. So when you get to like model experiment management, so you must talk to MLflow. We do have some of our customers do use MLflow for experimentation. I think we actually ran a recent hackathon, and one of the projects that came out of that was doing this integration as well. It's a very common tool that people use for experiment management, and you can integrate right out of the box and make sure. Again, versioning matters, right? Like the strong typing and strong versioning of your code, and what version of the model produced by what version of the code and so on matters. And most of these tools give you a way to like identify a particular like version of your model that's being served. So you can track all the way through Flyte, through these tools, through transformations and so on. So historically, inside Lyft, if you weren't concerned about ML, would Flyte exist? So in other words, if it was just data pipelines, would people just use people just use Airflow?
That's an excellent question. So funny enough, the Flyte isn't the first like version of orchestration we wrote at Lyft. Before my time at Lyft, there were like 3 different versions of workflow orchestration, and they started from the need for machine learning pipeline within the ETA group. right? So ETA is like, the estimate time of arrival for the driver. So you want to see that on your app at Lyft. How long will the driver be? And it's,
So how many
problem.
so how many models do you need before you decide cron is not enough, I need an orchestration?
So this was the first version, I guess. It was cron based with scripts sitting on somebody's laptop, and the trigger for revving that to a real system was that that person left, their laptop was reset, and the team lost the code, which will sound all too familiar to a lot of people. And that was a
but it sounds like
not happen again.
Yeah, it sounds like orchestration at Lyft has historically been really tied to ML.
I wouldn't say that. So the next step after that script cron-based system, there was an Airflow-based system. So we had an Airflow deployment, and one of the biggest Airflow deployments at Lyft. It is still being used for data. It was introduced back then for ML, was also subsequently used for data transformations and data pipelines, ETL jobs, and ML. The team built a library on top because Airflow at the time had a lot of limitations when it comes to data awareness and caching and whatnot, and versioning of the code and dependencies. There were a lot of problems. There's no containerization support, so there was a lot of limitations that was causing infrastructure problems. So the team for a couple of years was sort of fighting these problems with hacks and layers on top and so on. And then at some point decided to break away and build a system from the ground up. And that was the version again before Flyte. That was a version built in Lyft, completely custom engine, but it was built to work for Lyft. It was mainly used for machine learning models. That was sort of the break. So data ETL jobs continued to run on Airflow. And then ML models started being built on top of Flyte because all the niceties, I guess, around how you write them, how you track them, and so on. And then,
so what were when the first version of Flyte, what were the must-have features that were lacking, say, in Airflow or other options?
Oh yeah, the data awareness was one of the biggest. And
so define that. Define that for our listeners.
Is that I want to, when I have a workflow, I have 3 Python functions. Let's say I'm calling. I want to pass the output of the first one as an input to the second one. And if the author of the second function changes, the interface, now they require 2 inputs. I should know that at sort of compilation time, early on. I shouldn't really at runtime get surprised that, oh, there is this now missing parameter. So this data flow awareness within a workflow was critical for eliminating a lot of these sort of runtime or late stage errors, particularly when you think about a machine learning model that gets trained in hours or even days in certain cases. You don't want surprises after spending 10 hours training a model that something failed down the line. So you want to early on know about the data compatibility, data types compatibility, and the requirements for interfaces and so on. That wasn't. I think that was added later on at Airflow, but wasn't there in the beginning. And then the second thing was containerization, right? So dependencies, and anybody who has used Python without containers will probably tell you that this is a huge problem when you have, especially when you have to start getting into complex workflows with 5 or 10 different teams contributing different codes. Aligning on which pandas version to use can be a daunting task. So containerization, we saw that containerization is the key for solving this.
So let me stop you here. So for containerization, was Argo around at that point?
Was not.
Okay.
So that, yeah. So I think Kubeflow or Argo Argo started getting developed when Flyte, this version of Flyte started getting developed. Kubeflow was developed about, I would say, like maybe 9-10 months later on, and they sort of all came out around the same time, or went to sort of production around the same time. I would claim that the advantage Flyte had over Kubeflow or Argo was the sort of real-time, real-world usage of the platform. Like Lyft was using Flyte in production for over a year before it came out as an open source project. So it has a lot of history behind supporting, the mission criticality of these workloads. There's a lot of business critical applications that run at Lyft on Flyte. A lot of problems that worked out. There's like guarantees for there's no data loss and things that the big problems that can bring down a business, right? So this is why we can stand behind a strong statement like that.
So you mentioned data awareness, containerization. So what are there any other must-have features for that first version?
Those were the two critical features. The support. So that's what the two critical features for the existing teams. At the time as well, there was L5. This is Lyft's arm for autonomous driving, which is now as part of Toyota. Moving Planet, I think, subsidiary of Toyota. But at the time, it was part of Lyft, and the requirements there, it started coming out like sort of as a development partner. They were not running Python code for training, and they had their own proprietary processes that needed to run to process data, images coming from cars, and training models, and so on and so forth. So there was a need for a pipeline that's agnostic of what you're actually running. There is no requirement that I will run a Python function when I call the task, or that even my sort of library exists in that container. They had completely native containers that they wanted to run as part of this pipeline, and you couldn't really do that nicely, at least in Airflow. Airflow was built for Python developers, and it works very well within that limitation. Once you finish it out, you are on your own.
So let's stop at this point for a second. So I haven't used Flyte, so I'm not familiar with the API. So how do I build a basic pipeline in Flyte? First, purely Python, and then what if I want to mix and match?
Yeah, great question. So you get your Python. So let's say you want to have a pipeline. And sorry, before I say that, I think typically what we saw people do, they don't start thinking that they want to write a pipeline. People start with, I want to query
they just write code. They just write code, right? So people just write code, and then
I think that should be. Mm-hmm.
And then that code is an expression of the pipeline, basically.
Correct.
Captures the pipeline, right? So.
Yes. So the very basic pipeline you write in Flyte is some Python functions, and that you add task on top, and then a Python function that defines the data flow between these functions. It's call this function first, get the output, run a loop, call these functions in between, right? Which is just, again, Python code. But you say add workflow on top of that, and that's it.
So do you have to explicitly or make a big deal about DAGs in the Flyte model? No.
No. So what's the way we think about DAGs? And I know there's a lot of chatter, I guess, about this is a DAG or this isn't a DAG, and we
Yeah.
support non-DAGs and so on. So I think that the distinction I would love to make is when I am authoring a workflow, I shouldn't, or the platform shouldn't force me to think of a DAG. It's like,
Right.
no, you can't have cycles, and no,
No, like you said, I probably already have given a lot of thought into how I'm going to structure the program, which basically is the pipeline. And so make it easy for me to actually take my code and run it.
Yes. You shouldn't have to think of a different paradigm to writing that, like, workflows or whatever. It should just be your code. From that perspective, I am authoring a workflow. I shouldn't really think about DAGs, and we totally.
All right. So I get it for Python. So now I do something in Python, some data manipulation, and then I realize, oh, I have to run an algorithm in C++.
Yeah.
Then go back to. So how does that work?
Exactly. Yes. Yeah. So there's something in Flyte called reference tasks, which is basically you define the interface that you expect. You're saying this container, that C++ container, will take 2 inputs, 2 string inputs, and return me a string. You write it, essentially write an empty function in Python that has that interface, and you say this is the real implementation of this is in this image, container image, and that's it. You use it as part of your workflow, just like an existing Python function. You can mock it in tests, right? So you don't need to, if you are unit testing your workflow, you can say, when you come to this function, return this data, right? So there's like PyTest support. And then once you are happy with this, when you run it in the Flyte cluster, this will be replaced with the container. There is a sidecar that runs next to the container that takes care of transforming the inputs in Flyte lingo to native command line parameters, and then the other way around. When you return something, it will convert it back to what's expected in Flyte. And then the rest of the tasks don't care, right? They just take inputs, they return outputs. They don't know where these inputs came from, and so on.
So this is a hard question, but what percentage of Flyte users take advantage of this mix and match?
That's definitely a hard question.
Yeah.
We don't track, of course, all the users now specifically, that we are in the open source and everybody does their thing. But I can tell you that we see a lot of usage for this in the bioinformatics space. There is a lot of use cases of existing tools that do process data for biomedical fields, that are written in native programming languages, in C++ or C, or some things like that. And those are very heavy users of this feature. It's I will write everything I can write in Python, but then when it comes to these tools, I don't want to do rewrite them or do anything, right? I would just call this, invoke this external thing, come back with the results, and move on. So it's very heavily used in that space, and there are a lot of companies in that space using Flyte.
So who is using Flyte now? So you mentioned Lyft. Obviously, heavy usage within Lyft. So who are some other notable users of Flyte?
Spotify is a notable user. Black Shark AI.
Wait a minute. So Spotify created Luigi, right?
Yes. So they funny story. Yes. So I actually admire the journey there in Spotify. So Spotify, as you said, started Luigi, and they were very heavy users, obviously, of Luigi, and they at some point looked at the open source market, and they saw that there's other libraries and other tools leapfrogged what Luigi.
Oh yeah, because it's so old. Luigi is so old.
Yeah. So instead of sort of sticking their guns, it's no, we are standing behind Luigi and we'll keep working on it. They very reasonably decided to investigate and look at other tools, and they picked Flyte and migrated all the existing like workflows they have. And I think they published a blog post about that, like their experience and their comparison and why they moved to Flyte and so on.
So would you characterize so the people who use Flyte, they tend to use it for ML?
We definitely see a lot of usage of Flyte in ML.
Because like you said, if I'm just doing data workflows, data orchestration, data workflows, do you have people who use Flyte only for that?
Yes, there are definitely a lot of users that start with this. I would say they are generally, I wouldn't like split it as data or ML. I would say they are generally teams and companies that do recognize the need for a dedicated system that can guarantee, robustness and reproducibility and so on for orchestration. This is where the conversation usually starts. And once it's in, the use cases we see that keep sort of leveraging Flyte is just enormous. Within any company, like we see this story sort of repeats. There is a lot of use cases, not just within data and ML. There's like general process automation, right? You need a workflow orchestrator that can just work for you instead of forcing you to sort of like adapt to that tool. And because of the different use cases we saw Flyte used in, the tool is flexible enough to give you the very simple very simple like getting started, but also adapt with you as you change the use cases and grow into more complex.
So here's another impossible question. So what's the market share of usage of Flyte between data engineering and data science ML?
I think, unfortunately for that one, you were right. It is an impossible question. I am like excited and humbled really with all the usage we see in Flyte and all the companies that are playing with it now and are planning to or evaluating Flyte. It's a very hard to assess the market size, let alone assess the market share for Flyte. But yeah, we're humbled every day when we see new usage, new use case, new company venturing into this world, and we'll be happy to support them.
Well, so that good news for you. I don't know when we'll release our orchestration survey, but the number one use case there is, and this is over 500 respondents across all the open source projects, but the number one use case seems to be data science.
Okay.
Yeah.
So it's definitely traditionally more mature than ML. I think there are a lot of like we as an industry we started realizing that we need to transform data before we realized we should automate ML models. So there are more people doing that than training. So this is expected. I think more and more companies, once you have certain set of tools for data and transformation, your next step is into them.
So again, referencing our orchestration survey, which may or may not be out by the time I air this episode, the top two features that people cite as high priorities are ease of use and monitoring. So tell us about what's your story around ease of use and monitoring. Oh, by the way, funny enough, in this space for orchestration, it seems like one of the key differentiators among the different communities and vendors is actually this, because once you can imagine when you have a lot of workflows going around, you need a nice dashboard that is convenient, that gives you a lot of information in a very kind of concise and efficient way. So it seems like that monitoring and that dashboard is highly important for heavy users, right?
Yep. We at Union we have a dedicated team working on the dashboard for Flyte, and in this past year there are a lot of features that I would like encourage you to take a look at it. There are like some demos and so on for it on YouTube. So there are, absolutely right. It's like any feature we ship that doesn't really surface in the dashboard is as if we haven't shipped it. We noticed that it's that important, right? People work and in the dashboard like for a long time. So monitoring, you asked about monitoring, ease of use, and I guess the dashboard is part of that monitoring piece. For ease of use, we are like constantly improving the UX for how you use Flyte. We brought it down from maybe a couple of minutes to start this sort of sandbox cluster of Flyte locally to seconds. You don't really need to think about building container images. You just need to think about writing code, and that we see a lot of improvement there. Even like the trick there isn't to just eliminate the requirement for containerization. There are some tools that don't require you to have containers. Flyte continues to, but the trick we realize or we think is that we make this process seamless. We continue to give you the guarantees of containerization with the ease of use of I'm just writing code. I don't need to think about Docker files. I don't need to know how to, pip install requirements and all of that. It all sort of just happens for you. And again, scales with you. Once you get into more complex use cases, once you want to have different Docker images for different tasks, Flyte is again there for you. So use case I see as a sort of a spectrum, as opposed to I just want to start with writing code. That definitely is where you start. But every step as you grow and as your use cases grow, you need it, the tool needs to be there helping you make that bigger, more complex use case easier as well.
So would you say going to ease of use? So what's the sweet spot persona for Flyte? Is it data scientist, data engineer, developer? So in terms of what you're seeing, who's using Flyte, does it tend to be the more technical persona, or is it more democratized?
I would say more of the data scientists and ML engineers than like software engineers. Funny enough, in all the companies, I want to say most, just in case I missed a couple, the companies that deployed Flyte, the appeal was very strong on sort of both sides of the equation, which is the people who will run the platform folks who will run Flyte, like who will run a cluster and maintain it and grow it and so on, as well as the people the end users who will use Flyte to author workflows and tasks. And those are the data scientists and ML engineers. And we want to make sure Flyte appeals to both camps, because you don't want a tool that people love to use, but it's a nightmare to deploy and maintain for like infrastructure folks. And you also don't want the other way around. You don't want a tool that's that helps the in-platform folks monitor and deploy and migrate and so on, but it's like terrible to use. And we see definitely tools that error on one side or the other. The advantage I think Flyte has, given that the same team that built Flyte was running Flyte at Lyft at scale. I think before we left, there were like 20,000 workflows with like, tens of millions of hours of usage a month. So it was a very decent scale. So we have experience, we understand the pain of running a platform in a company when we make sure Flyte works well within these tools. But we also made sure because of the diverse use cases Flyte had, that it appeals to a wide range of end users for the platform.
So here's a big technology trend, or just a factoid, right? So if you look at people who use data, you've got data engineers, machine learning engineers. There's fewer of them than obviously there's fewer data and ML engineers than data scientists. But then the biggest group by far is analysts. And now I'm starting to see low code and no code tools to target analysts so they can do simple data integration and in data transformation, and maybe even build ML models using AutoML. So is there, I guess, an orchestration tool would be able to support analysts, because analysts would not even know that they're using an orchestration tool, ideally, right?
Yep, that's I think if you have the right tool with what they call a layered approach, right, where you can start on the top with a very simple use case, but then if you have more complex use cases, it lets you sort of peel layers and dig deeper and use the more basic.
Or based on your model, it's just basically analyst is using this low-code tool and it's going to connect it to this other low-code tool, and then you're just doing that stitching, right?
Yep. So, but as you said, I think if I'm building this tool, and Flyte isn't that tool that analysts can use directly, but if I'm building the tool that analysts would use directly, I would choose an engine that can support this use case, but also supports the eventuality of data engineers getting involved in these pipelines and wanting to write code and modify these tools, modify the pipelines or the tasks or the queries or whatever. I think it's, and I think the approach of no code has been sort of hovering over the industry for a long time, for tens of years. It's like, yeah, we will like deprecate developers and we will write like, and there is certainly a set of use cases where that is very appealing and very strong in doing. But what we saw is that if you only build tools for this, you are like screwing up people who will come late and they were like, it's not quite working for us. We want more. We want to write a piece of code in this, but we love the rest. Like we want to keep the workflow as is, but I want to replace this step with my code. Now what? Right. So I would, if I'm building this tool, I would pick a tool, the quick workflow engine that lets you, when needed, expose the internals and replace with your code. But that's, yeah, there is, like, as you said, this is a growing field. I'm excited to see, what tools get built in that space. And if Flyte can be part of this, I think that would be awesome.
So you alluded earlier to Flyte was being used inside Lyft by kind of the self-driving car division, which brings me to another, I think, trend that is right around the corner, which is this notion of multi-modal models, right? So right now, most of the things probably that we've talked about so far, the listeners may interpret as applying to structured data, maybe text. But the reality is now we have more sources of data, computer vision, right? So maybe audio even. So machine learning right now tends to be a bit siloed, right? So you build a computer vision model and that's it. But I think we're kind of at the cusp of people using different data types and blending them together and building a more global model. Yep. But it sounds like you folks already have been used in those situations.
Yep. I think we were lucky enough that some of the currently, I guess, hot topics in ML models are use cases that already run on Flyte. So we have seen it and we have adapted. We see a lot of importance to strongly typed data structures. And similarly to unstructured data usage, and being able to mix the two, as you said. one of the critical pieces from an orchestration perspective there is allowing people to define what's like a structure, I guess, for unstructured data, or some expectations for unstructured data that allow them to run like, their training and so on with some predictable results or some predictable behavior. And there are like data validation integrated into Flyte, structured data, and so on, and like of course, native just files and folders support for raw data. But yeah, it's exciting times really to be in, as when compute is strong enough now to process these huge amount of data from different modalities. Yeah.
So how does Flyte relate to other execution engines? So for example, Ray, right? So Ray is a distributed computing framework that people at Astronomer and Airflow use as a backend, and people at Prefect use it as a backend as well. So does Flyte integrate with some of these other external?
So we don't integrate right now with Ray, though we are looking into that.
I can make that happen. I'm an advisor to Anyscale.
Okay, awesome. Yes, yeah. Please connect us. Would love to chat.
Oh, really? Yeah, I will do that.
So Flyte integrates with a similar architecture tool like Spark. Spark also runs with this model of a driver and executors, and it tries to take care of transforming data between and doing parallel processing of data and so on.
That's great. I'm also an advisor to Databricks.
Say again?
I'm also an advisor to Databricks.
Okay, awesome. So the same model works just right out of the box with Flyte. It's a pluggable, as I said, model. So you can define a plugin.
So that's the Spark integration must be popular, right?
Very, yep. So what we saw with Spark though is that a lot of people, there are like wide range of expertise when it comes to Spark. There are people who know they need to use Spark, but the team isn't an expert in writing Spark. And Spark can be daunting if you want to write, very efficient, well-structured Spark application, right? Knowing the intrinsics, the details of how do you, distribute the data or how it does distribute the data and so on. There are a lot of people who want to write regular Python code for, I just want a map job. I want to just write this massive map job on distributed data, distributed platform. And right now they sort of have to do that on Spark. They can, start their own, what is that tool called for batch processing for but anyway, they have to learn some tool to do that. Flyte does give you this sort of out of the box for simpler use cases, but if you need to use Spark and write PySpark or Scala or Java for Spark, you can use Flyte you can use Spark in Flyte for that one task, right? But then
what about Spark SQL? If you want to,
you can query data through Spark SQL as well. And there are teams that do that at Lyft. But again, the point here is you're not forcing the rest of the pipeline to be written in Spark if there is no need to. Right? So you are sort of picking the right tool for the job. Right. If I need Spark for this part, I will write it in Spark. If I don't, you don't have to. If I'm querying dbt for the data, then I don't need to, mash it into Spark SQL because I have to write Spark. And we think of these tools as extensions of execution engine that way. You should know when to use them. You should be very easy to use them and well integrate them in the rest of the pipeline, but we shouldn't force you to use one or the other or to compromise. You can imagine that maybe one day you will write a workflow that queries data from, let's say, Snowflake or dbt, run a array job to do some data processing on the data transformations. They run a Spark job on the Pandas data frame that was generated using, PySpark, a data frame transformer, do some more processing, and then produce the model or something, or train on a distributed TensorFlow model afterwards, right? And there is no forcing. We're not forcing you to use one of the tool, one of the other. These tools would just pick the one that works best for the step you want to do.
Yeah, and by the way, Spark now is like one of these things that if you're a data engineer, you must know. Just about every data engineering job requires it, right?
That's definitely true. Even like that being said, the level of expertise varies a lot. There are people who write Spark but not optimize it. There are even now people who take certificates in optimizing Spark. If you, I know you know that.
So let's close with, okay, so Flyte today and Union.ai.
Yes.
So what are some kind of things on the roadmap of both of these things? And yeah, so on the open source, what's something very important on the roadmap, and for Union.ai, what's something very important?
So Flyte is part of LFAI and data. So it's completely open source, completely managed and governed through open source. And there's a steering committee and all of that. One of our sort of biggest milestone out of or the next for Flyte, I would say, is pushing the envelope even further when it comes to these machine learning experimentation processes. There are, of course, a lot of improvements like smaller improvements everywhere across Flyte that happens all the time. But I think the next leap will be just changing or giving people a way to run from the start to a deployed model in production with production grade monitoring and all of that in seconds. The process now at best takes hours because of the cost of learning new tools, the cost of discovering and experimenting.
So what makes this challenging for you folks as a team to pull off? Is it the number of tools you have to integrate with? So what is the key technical challenge?
The number of tools that we will have to massage to work together well, so that from a user perspective, you get this cohesive experience. You don't have to think about jumping between tools. Is definitely a challenge. The biggest challenge, I would say, with all of our work at Flyte is the UX. Like we can integrate things, but I want to give it to you in a way that's
ease of use,
and just makes sense. Yep. Union, we started Union about 1.5 years ago with the purpose of making Flyte even easier to get adopted in companies where there's even maybe smaller infrastructure teams with or smaller expertise on Kubernetes and so on. And we announced the seed round a couple of days ago. A couple of days ago now, as of the recording time of this episode. We're working hard at making Flyte super easy to use, getting started with Flyte, and just jumping from I'm playing around with workflows to I'm running things in production. That we want to minimize that to.
So what at a high level, what is the key difference between Flyte and Union?
So we're working together. We are the core maintainers of Flyte.
But in terms of the if I'm going to use something,
Yeah, so out of the box, you should expect the full spectrum of Flyte features. There are things we can do at Union that we, just because of the nature of open source Flyte, we cannot do. So we can offer integrations, vertical integrations with other paid tools, with other open source tools and deployments and so on within Union, because we can give you this experience because we're managing and maintaining the infrastructure that we can ship with in Flyte as an open source tool. And that will be the main differentiator that you will.
So there's nothing on the on performance side, that there's no distinction on the performance side.
I cannot speak of that at the moment,
Okay.
but there will be improvements all across the board because we are allowed to do a lot more
Right.
at Union.
Right,
Is what I can
right,
say.
right,
Yes.
right.
And stay tuned. We hopefully will keep announcing the seed round, and the announcement of the wait list for Flyte was just the first step. As weeks go by, we'll keep announcing new things that we have been working on at Union.
All right, and with that, thank you, Haytham.
Okay, thank you, Ben, for the opportunity. It was great chatting with you.